Think that A does not belong. Raise your hand if you think that B does not belong. Raise your hand if you think that C does not belong. And raise your hand if you think that D does not belong. Okay, so it's not a competition. They all don't belong in some way. Now, Austin, why did you say that A does not belong? 0 for the X or the Y? Both, actually. The only one that starts at 0, 0, or what else do we call that part of the graph? Good, the origin. So, yeah, that would be 0 for the X and 0 for the Y. And it is true, no other of the graphs start there. That's the only one that starts at the origin. Ricky, why did you choose B is not belonging? Oh. Who chose? Oh, I'm again who chose B. Ricky, why did you choose C is not belonging? Okay, and when it's dotted, we call those discrete graphs. The rest would be considered continuous graphs. So like, I don't know, dotted, discrete, they both start with D. Ones that are continuous, so there we go. And Brianna, why did you choose B is not belonging? Brianna D. Okay, it does. It is the only one that decreases. And it has a specific name in math for that type of graph. Well, it is. They're all linear, actually. They all would create straight lines. But something about straight lines that we would say, like, instead of just saying it decreases, it has a negative. Good. It's the only one that has a negative slope. Which, yes, in more simple terms, does mean that it's decreasing over time instead of increasing. Now, I know you guys didn't pick B, but take a look at B again. How is graph B different from the other? Austin? Okay, good. So the titles on the axes are switched. The rest of them have hours on the x-axis, which usually makes sense. Usually, if one of the things you're comparing is time, usually that will be on the x-axis. But for some reason, they have it on the y-axis. Do you guys remember the other things we call x? Like in any situation, it's the what? Input and independent variable. So input and independent both start with in, so that's what you can remember. And then also, I showed you this yesterday, you can make an I with the x-axis and a D with the y-axis. I being for independent. Technically, you can make an I with the y-axis too, but you can only make a D with the y-axis, so that's why this works. The y is always what's dependent on the x. So for whatever the situation is, the hours depends on the dollars. Now, again, usually if one of your increments is time, usually that's independent. Usually, like, you cannot change time. So that is usually why it's x-axis. So for whatever reason, their variables are switched. The rest of them have time on the x. Questions on this format? Okay, so today we are on lesson 5, which is equations and their graphs. Let's go over the goals for today. And it's to graph equations in 2 variables by using graphing technology. And yes, we are focusing on linear equations right now. Linear is actually like what this unit is called, is linear equations and inequalities. so far up to this point, we've been focusing on solving equations and making equations from a situation. Now we get to graph them and identify the solutions to those equations. You need to understand how coordinates of the points on a graph of a linear equation are related to the equation. And that when given a graph of a linear function, you can explain the meaning of the points in terms of the situation it represents. I'm recording right now. I always update the lesson every year so that the things I'm saying right now are captured almost like a little digital footprint, so that way you can't say I didn't tell you about X, Y, and Z, so it's recorded. But if you're ever working ahead, like I usually will post the whole week at a time. That's why this link is in there. The mouth is always the same. The practice is in Schoology. Usually they are not very long. And usually they are really good, like quiz and test style questions. It's not just having you do the same task like 20 times. It's really good questions that if you are actually trying it yourself or asking questions, if you get stuck, then you will do good on the test. If you're just cheating, because it's super easy to cheat, I understand. If you're just cheating, like you probably won't do good on the test. But hey, you'll have 10%, which is not enough to pass, but that's there for you to practice. And I did grade your constructive response retakes, and I put those grades in the grade book. You guys did grow, I forget by how much, maybe like 8%. Period 1 had the most growth, and it almost even surpassed you guys. But you guys still are the highest so far. However, I will say like with a smaller class, it's easier to have like higher averages, but still really good. And anything further that you want to do to improve either of these scores would have to be done during tutoring. So there's some Strive stuff that I still need to grade and plug in, but other than that, like that's where you're at. So we don't have any assessments this week. Be prepared for the next 3 weeks to have a quiz on Monday over whatever was learned the week prior. So make sure. Normally they just happen during the week. This year I've managed to put a lot of them on Mondays, which gives you the weekend to get your notes caught up, the weekend to do your practice, and making sure you're ready for those little checkpoints. Any questions? So again, we're only like now 6 lessons in. You can still catch us and you can still finish off really strong. So it's all there for you to rewatch and everything. All right, so first situation today. To get snacks for a class trip, Claire went to the bulk section of the grocery store where she could buy any quantity of a product and the prices are usually good. Claire purchased some salted almonds at $6 a pound and some dried figs at $9 per pound. She spent $75 before tax. You're going to answer each part, and then there's a fourth part that isn't on here, but you can still try and answer it too. So if she bought 2 pounds of almonds, how many pounds of figs did she buy? If she bought 1 pound of figs, how many pounds of almonds did she buy? And then write an equation that describes the relationship between the pounds of figs and pounds of almonds that she bought and the dollar amount that she paid. If you use a variable, make sure you tell me what that variable represents. And then there's a number 4 underneath it, but we'll go over these first 3 in about 3 minutes. Any questions? So try those out, and you're in groups to kind of help each other, but you know, if you end up being the reporter, you'll have to be the one explaining it so you understand. And if you paid attention to the learning targets, we will be using graphing technologies. So I'd say like you might as well get it out now, because you'll probably need it for some of the multiplying and dividing. So table 1, if she bought 2 pounds of almonds, how many pounds of figs did she buy? Pounds of figs. And what math did you do to get that? -5 -9. Okay, and then we can do anything else. What is 75 minus 9? It's 4. Okay. So then what do you do with 66? Which gives you, and that's not 7. Minus 75? Okay. All right, and then what? Minus 9x is 7. Okay. Do you hear that? Yeah. Do you hear some of it? What part do you not agree with? Yeah. The 63 minus 9, what would you do instead? Okay. So 63 divided by 9 gives us 7. Which if you did 63, what did you say again? Minus 9x. Said equal 7 like that. If you just had this and you moved this across and made it like 63 equals 9x, so like you have to add 9x to move it to that side, and then you divided 9, that would work. But this stretch work up here is the math that you would do to get the answer. The answer is 7. However, if you were to make the equation, that would be a more organized way. And like you kind of saw, and it happened in first hour too, it's hard to like keep track of the work that you did to see if it's right. When you're just kind of like reasoning about it. And anytime like I teach my students how to solve equations, there's always someone that says, hey, Miss Medina, I did it a different way. And then they explain it, and it's literally the same thing that I did, just they're telling me verbally, because I'm like, yeah, I also subtracted 12 on each side. I also divided 9 on each side. But making the equation, if you guys did that as your first strategy, would be better than it's just like a process that you follow. So did someone get the equation for number 3, Peyton? It's a little louder. All right, and what is A representing? And what is F representing? Okay, good. So class, does it make sense that for however many pounds of almonds, she's multiplying by the price of almonds? And then however many pounds of figs, we're multiplying by the price for each pound of fig. And then the 75 is the total amount paid. So if you started there and you were given this information, you know, she got 2 pounds of almonds, I would make sure to plug it in for the almond variable. Plus 9f equals 75. Now you kind of have a more organized process. So first you'd simplify to 6 times 2, which is 12. And now it's just a 2-step equation. You would subtract 12 on each side, which is what they said was their first step. We get 9f equals 63, opposite of multiplying by 9 is dividing by 9, which is their next step too. It's 63 divided by 9. However, this is a little bit easier to follow and explain. All right, so questions on the answer for number 1, 7 pounds. All right, table 3, whoever the reporter is, can you tell me if she bought 1 pound of figs, how many pounds of almonds did she buy? 11 pounds of almonds. And now this time I'll check it in my calculator. We have the structure of what the equation should be. So if I were to plug in, 1 or 11 pounds for the almonds and 1 pound for the figs, for the A and the F, and they equal 75, then it is a solution, which is something you would have done on your homework yesterday. So that's 6 times 11, you guys said, for the almonds, plus 9 times 1 pound I said you got, equals 75. That is a solution. So 11 is the answer for that. Good. Any questions on the fuel oil situation? Right, we're just going to add one more thing to it. So you kind of see on your paper, you have a graph. You're going to choose, well, first let me explain the graph a little bit. So notice what they have on the axes. They have almonds as on the x-axis and the dried figs on the y-axis. I know we were talking about like independent versus dependent. In this situation, these both kind of depend on each other, but pay attention to how it's labeled, because sometimes when you graph it, you'll have to determine like which one is independent, which one's dependent, or which one has to be the X. So on the X-axis, it has the almond, so I could switch this A for an X. On the Y-axis, it has the figs label, so I could change that 9, or not the 9, the F to a Y. And this would be something that I could use graphing technology to produce. I just tried it earlier, Desmos was being even like way more user-friendly than it normally is. Normally, if you type in this, will not get a line because Desmos doesn't read A and F, they read X and Y. But this still goes for like your handheld graphing calculator, like it probably only reads X's and Y's. So that's why I'm pointing it out, so that it could be something that you can graph with graphing technology. But then you need to know how to read it. That's what this part is. First, you're going to choose a point that's on the line. Tell me what its coordinates are and explain what it tells us about the situation. So remember, coordinates go in the order X and then Y. So that's a little trick for that part. And then choose a point that's not on the line, state its coordinate, and be able to explain what it tells us about it. A. And normally point, coordinate, ordered pair all mean the same thing, but this one has ones that are labeled that you could pick from. Really, you could also pick other ones too, as long as they're on the line. But yeah, point A is on the line. Table 4, can you tell me the coordinates of point A? 2, 7, good. So that's 2 for the X, 7 for the Y. It always goes in the order X and then Y, just like that, with parentheses and a comma. If you chose C, class, what's the coordinates for point C? Close. Yeah, that definitely does look in between the 6 and 7, so 6.54. And then for B, what's the coordinate? Okay, good. That's a really important skill. Can I identify coordinates? Looks good so far. Now, for the one that they chose, we need to explain what it tells us about the situation. So I know a lot of you kind of want to go to like the math of it. I could tell that from your last test. when it asks like, what does the median tell us about the situation? You told me it's the middle of the data, you gave me the math definition. Whenever it says like what it tells us about the situation, we want you to go back and read like the little story that went with it. Now, if you have a graph and it's labeled already, that makes it so much easier. Because you just have to look. Okay, X usually comes first in the coordinate. What's on my X-axis? The pounds of almonds. So that means that she bought 2 pounds of almonds. And what's on the y-axis? Asking all of you, what's on the y-axis? Okay, can more than 2 people be able to tell me that? What's on the y-axis? It's labeled. So she bought 2 pounds of almonds and 7 pounds of dried figs. I'm just gonna put figs. And it's on the line, so that tells us that it met the constraint. So like it equals the 75, so you can add or 75. So that is important. It's on the line, that means it meets the constraint and makes the equation true. Those pairs are solutions to the equation. Questions on that? I'm pretty sure we did that one earlier. 2-7 was like the answer to number 1. All right, table 6, whoever the reporter was, what's a point that is not on the line? 14, 0. And that's point E, if you guys want to have that in. But that is the coordinates of the E. Point, coordinate, ordered pair, they're all talking about the same thing. And that is why it's on the x-axis, because the y is 0. Anytime the y is 0, it's your x-intercept. The other one you could have picked, or really you could have picked any other point that's not on the line, but this one's outlined. Class, it's the coordinate of point D. 1, 1. All right, now for what it tells us, the 14, 0, what it tells us, that's 14 what? So that's 14 pounds of almonds. Again, that's the x, so the x-axis. Otherwise, you're having to go back and read the story and figure out what's independent. And then 0 what? Pounds of figs. Now, would this total to $75? No, because it's not on the line. So if she buys 14 pounds of almonds and 0 pound of figs, you can add something here. It does not cost $75. Because the thing that's graphed was for this equation. Questions on that? Okay, so then now let's look at a new situation. So on the back, let's do the one about money, because that one will probably be important to you a little bit more than if something is losing water over time. So on the back, we're going to look at this one. So a student has a savings account with $475 in it. She deposits $125 of her paycheck into the account every week. Her goal is to save $7,000 for college. Be able to answer these questions. How much will be in the account after 3 weeks? How long will it take before she has 1,350 saved? Write an equation that represents the relationship between the dollar amount in her account and the number of weeks savings. B, where we graph it using graphing technology. I'll show you how to do that. Was the answer to top 3. And then for how long it'll take her to reach her goal, we can answer that with the graph. So really just parts A, B, and C for right now. And then we'll switch up the reporter, so it could end up being the same person depending on what I say. Could be somewhere different. So just make sure we're prepared and not be mixed. Okay, Dexter, how much will be in the account after 3 weeks?
750.
750. And how did you get that?
Because like I added 475 plus 420.
Why 425?
475.
But then you said, I thought you said added 425 to it. What did you say?
120.
Oh, okay. And you added 125 to it how many times? Just once?
Three times.
Okay. So then, yeah, the 475, because that's already in her account. And we know that each week she is depositing 125, so it makes sense to add the 125 3 times. I heard you say 750. Did you mean 850?
Yeah.
Oh, okay. That would make more sense. That's what my calculator says. Which is a way of getting the answer. How else can you guys condense this like 125 plus 125 plus 125? What times 3?
120.
Okay. So repeated addition of the same number is what multiplication is. So there's that. You could have also written it like that and gotten the 850. Now, whoever spoke for your group the most recently, go one to the right. That will be the reporter. So table 2, how long will it take before she has 1,350? 7 weeks. And how did we get that? Oh, okay. So you said from, so that means I have to switch the order. So 1,350 minus 475, okay? Okay. Sorry, I heard something weird, so I'm gonna check in my calculator. 875. And then you're dividing it by 125. Okay. Which does give you 7. And that is a solid way of getting the answer. These ways that you guys described it to me would be by reasoning, which is okay as long as you get the right answer. Now let's make an equation so that you can easily solve no matter how many weeks, no matter how much money we want to figure out, and so that we can also graph it. Table 3, what is the equation that represents that relationship? And what? Okay, and T is gonna be what? Okay, so T is for total. Save. And then W would be for the number of weeks. Okay. Now, I mentioned before, Desmos probably got like an update and now they're even more user friendly than they were before. But ordinarily, you'd have to figure out which one is independent and should be the X. and which one is dependent and should be the y. So what do you guys think? Does the amount saved depend on how many weeks have gone by? Or is the number of weeks that have gone by depend on how much was saved? But think about that. Remember, what's dependent goes on the y. So whatever depends on the other thing goes on the y. What should go on the y-axis? Yep, that is what I just said, but of the two things being compared. Which one is dependent? The total saved. Which means then the weeks, the number of weeks goes on the x-axis, which makes sense. Usually if one of them is time, that will be your independent variable that should go on your x-axis. Which means normally, doesn't will work either way, it seems now. Normally I'd have to switch this t for a y and the w for an x so that it could actually graph it. So if you have a handheld calculator, that's what you'll probably have to do too. All right, but to graph it with graphing technology, you type in the equation that you made or that you're given, and you can see some of the answers we already said, like for 1A, a Amparo solution was 3 for the weeks, which is on the x-axis. That's why I'm putting it first. And 850 for the amount saved. I can zoom out and see where the red dot is. See if it's on the line. If it is, then that's a solution. All right, 850 on the y, 3 on the x, and you can label it if you even wanted to do that. I said earlier, usually, like if I were to type in T and W, it doesn't work, but I guess it works now. But still, like you should get into good practice of knowing what should go on the X and what should go on the Y. So there's that. For 1B, the pair was 7 for the weeks and 1350 for the Y. Notice I'm not putting a comma between here because then it can't read it. It reads the comma as separating the X and the Y. So make sure you pay attention to that. I have to zoom out because 1350 on the Y would be way up here. Zoom in and you can see better that it is on the line. All right, so everyone see that? Any questions? Now, for how long it will take to reach her goal? Well, what was her goal? 7,000 saved. So I could also use this to zoom out, find 7,000 on the Y because it would be dependent, right? How much she has saved depends on how many weeks have gone by. 7,000 is way out here, so I had to like zoom out. I can zoom in to where I can click on the line and drag to where it's 7,000 exactly. Let's see if it lets me. Oh, there you go. Everyone see that? So that X value is going to be the weeks it takes for her to reach 7,000 for her goal. So she reaches it in 52.2 weeks. I don't know if it would want you to round up or not, but it takes her exactly 52.2 weeks to reach her goal. You would have to probably round up to get the right answer though, depending on how like specific it wants you to be. At 52 weeks, she hasn't met the goal yet. By 53 weeks, she'll have met the goal. All right, but that's how you can do it. You could click and drag. You can check your answer and see if it's right. 52.2, comma, 7,000. Right, and if it's on the line, it's a solution. All right, any questions on that? All right, would you like to do one more or would you like to work on your practice? Okay. I mean, the one underneath it is very similar, so you could, like, if you wanted to try it, and I'll tell you if you're right. But then you do have a practice, it's 2.05. Everything else should be done up to that point. If not, you have a lot of catching up to do, but it's still possible.